Hi, welcome back to day 2 of 2.2 Skills for Working with Rational Expressions. Today we're going to focus on adding and subtracting rational expressions. So we have a few steps kind of similar to multiplying and dividing. We first are going to start off by factoring wherever possible. So factor the denominators and factor the numerators as well. Once we've done that, look at the denominators and then determine a lowest common multiple of the denominators. Okay, we actually call this, when we do this, we're actually finding the lowest common denominator, the LCD. Okay. And then once we've done that, we can rewrite the expressions with the common denominator, and then we'll add or subtract the numerator, whatever it's asking us to do. And then we just simplify and state restrictions. Okay, let's go ahead and do our first example. So we have something pretty simple here, 1 over 5x plus 1 over 2x. So these are just considered monomial terms because they're just single terms. Okay, and if I want to add these together, if you remember to add fractions, you need to have a common denominator. So let's just do a quick practice real quickly. So if you wanted to add 1 over 3 plus 1 over 4, well, to do that, we need to get a common denominator. So to get a common denominator, we actually have to look for the lowest common multiple of those numbers. So a number that 3 can go into and a number that 4 can go into. So you might have guessed that number is going to be 12. So in order to make 3 12 right here, our first denominator, I got to multiply this by 4. And whatever you do to the denominator, you need to do to the numerator. So now I actually just have 4 over 12 for the first term. The second one, because the lowest common multiple was 12, I need to multiply this by 3. And whatever you do to the denominator, you have to do to the numerator. And I would get 3 over 12. This just works out to 7 over 12, because once you're adding fractions with the same denominator or common denominator, you just do the operations to the numerator. So 4 and 3 gives us 7. And then I would simplify this, but 7 over 12, can't do anything with that. So one thing I do want to add, remember when I said whatever we do to the denominator, we need to do to the numerator? We do that because we don't want to change the value of this. So by multiplying both of those by 3, I actually keep the same proportion. So 1 over 4 is the same as 3 over 12. So I can't change the form of this. I can't change the value of it. I can just change the form, right? So, okay, that's what we're essentially going to do with this example here. So let's go back to blue here. Okay, so we're gonna start by determining the least common multiple or the lowest common multiple. Okay, I'm going to call that LCM for short. So this is just of the denominators, right? Of the denominators. Okay, so 5x and 2x. So what's the lowest common multiple? What's the lowest or the smallest expression that both of these fit into? So my lowest common multiple is going to be, so if you have a little bit of a hard time doing this, you can always take them, you can always write them out and then factor them. So like for instance, 5x, that's factored 5 and x, and 2x is just 2 and x. So together, I can kind of create something that's going to be common. So I see they both have an x in it, so my lowest common multiple should have an x. And I also see that we have a 5 and a 2, so both those go into 10, so I could just write 10 in. If you're not sure, you can always just write them in here, 5 and 2, and then that gives us 10x. So that's one way of finding the lowest common multiple. So So this is our LCM. So basically what I need to do is I need to make these denominators look like this. So I'm gonna have to multiply this by something to get this, and whatever I do to the bottom, I gotta do to the top. That's kind of how these work. So our 1 over 5x, that's gonna turn into, I'm gonna have to multiply by 2, right? In order to get 10x, I gotta multiply that by 2. So whatever we do to the denominator, we gotta do to the numerator. So that's going to end up being 2 over 10x. Okay. My second term, so this part here, 1 over 2x. In order to get the 2x to become the 10x, I got to multiply by 5. Easy peasy. Whatever you do to the denominator, do the top. And we're going to have 5 over 10x. Now I have the common denominator. I can just add the numerators. So 2 and 5 add up to 7. So we have 7 over 10x. Can I simplify this? No, I can't. So this is finished. I just need to state any restrictions. So x cannot be equal to, and I can take a look at the start. X can't be 0. That would be dividing by 0, and those would be undefined. And none of that really changes as we move through. And I look, it's still the same. So we just say x can't equal 0. All right, that is the first one. Monomials are kind of quite simple like that. It's pretty easy to find the lowest common multiple. When we start to do other ones, then it can be a little bit trickier, but I think as you kind of follow these steps and practice them, you'll be just fine with them. So, okay, let's start the next one. So I'm gonna kind of get this out of the way here too. All right, so let's first start by finding the lowest common multiple. So we're going to take a look at what we have in our denominators. So we have 2ab squared for the one, and we have 2b for the other. So when I factor these, we're going to have 2 and a, and we have 2b's, because b squared is actually just b times b. And the other one, we have a 2 and then times a b. So we can already see we have some common factors in here. So it's going to make this easy to get the common multiple. So I have a 2b here, and I have a 2 there and a b there. All I'm going to need is another a and b to get a common multiple. So together, we should have a 2 times an a, and then times 2b's. That way, all I can see is I actually don't need to do anything with this here to get this. This one, I just got to multiply by an a and a b, and then I'll get that right here. So I can see this is the lowest common multiple of these two terms. So you can clean this up. You can just write it as 2ab squared. So I'm kind of spelling this out. You might be, pretty good at this, and you might look at these and go, oh yeah, okay, I see a 2 here, a 2 there, that's good. I see a b squared here and a b here, so I know I'm going to need an extra a and an extra b with this one in order to make this the same as this. So, and you now figured out your lowest common multiple, so you can totally do it that way. All right, so we'll write out ab squared plus 2 over 2ab squared. And remember, this already is the lowest common multiple. I don't need to do anything with this term here. Okay, I'm just going to write my equal sign here. We can't forget to do that. Then we have minus. The next one, b plus 2 over 2b. This one I need to multiply by an a. So I'm going to write it like this. We'll have an a and a b on the bottom. And I also need to do the top as well. That way this will now look the same as that. And notice every time, whenever I do the denominator, I do the numerator so that I'm not changing the value of anything. All right, so we're going to have, just to make this look a little cleaner, we can say ab squared plus 2. And I'm going to make this all 1. So I have the common denominator. I just now need to subtract the numerator. So I essentially have this times this. So that's actually how I'm going to write it. I'm going to write minus b plus 2 times ab. And this is all over 2ab squared, the common denominator. Now we just have a little bit of work to do here. So I'm going to distribute this in. So I know it's kind of backwards distribution. We're going to take AB, we're going to multiply it into this bracket so that we can take care of that. So we have we have AB squared plus 2 minus, I still need to keep this bracket. So AB times B is going to be AB squared because the B times B becomes B squared. And then we're going to have plus the AB times 2, so we're going to plus the 2AB. And that is still over 2ab squared. Okay, and I just need to make a little bit more room. So I kept this bracket here. It's important because we're subtracting this. So in order to drop these brackets, I got to multiply the -1 into each. So we would have ab squared plus 2. Then we're going to have minus an ab squared and minus a 2ab. So don't forget, you got to multiply this and this by -1. So they just get opposite signs. And all that is over 2ab squared. And you can see something nice kind of happens here. We have an ab squared minus an ab squared. So we know those are identical, so those are going to cancel out. And I'm going to be left with 2 minus 2ab over 2ab squared. Now, this is not factored up here. So you don't want to cancel anything out. You have to be really careful. What I suggest you do is you factor the numerator. And we're almost done here. We're going to factor out a 2. And we'll have 1 minus ab over 2ab squared. Now you can see this is in a factored form. And I can now cancel out a common factor. So I can get rid of those. Divide both by 2. And we're left with 1 minus ab over ab squared. Now I just need to state any restrictions from along the way. So I have two variables, a and b, and I can see that from the get-go, both of them can't be 0. Okay, and the ab is always present throughout, so we only have those restrictions. We'll just say a and b cannot equal 0. Okay, and that's it for those two. Okay, we'll now look at the next example. So we may need a little bit more space for these, so just be a little bit careful when you're writing this in. I'm going to write large and I'm going to compress it like I have been doing in the other examples. So we want to add these two expressions. Okay, they're both binomials, same here and here, and we're just adding them. So I'm going to start this over here. I'm going to write it in here and then I'm going to move it over here afterwards. So, okay, x plus 5 over x minus 3 plus x minus 7 over x plus 2. So I don't see any common factors with this. Okay. So there's no common factors. So our lowest common denominator, our lowest common multiple, is just going to be this times this. Okay, so I'll write that out real quickly. I'll just say there are no common factors. So the lowest common multiple is going to be x minus 3 times x plus 2. So I'm going to try to get each denominator to look like this. So that one and that one. Okay. Whenever you get something kind of odd like this, where nothing is the same, we just need to multiply the two together. So it's pretty easy to get the lowest common multiple for those. So start by writing out that first expression, that first rational expression. And then I can see in order to obtain this lowest common multiple, I need to multiply this one by an x plus 2. Numerator and denominator, both. Okay. And then for the second one, I'm going to multiply this one by an x plus 3 in order to go from here to here. Okay, I already have the x plus 2 part. I just need to multiply it by an x plus 3. So whatever we do to the denominator, we're going to do to the numerator. Okay, now we can just multiply straight across, right? So we'll have x plus 5 times x plus 2. That's going to be over x minus 3 times x plus 2. That's the first expression here. And now we're going to write out the next one. So x minus 7 times x minus 3. That's going to be over x plus 2 times x minus 3. Okay. At this point, don't do any canceling out, right? With the common factors, you're just going to end up going back to what you started with in the question, right? The reason why we have those there is so that we can have a common denominator, right? And then we can add them. So my next line, I'm just going to add the numerators. So we could do like a little bit of FOIL at this point if we wanted to, but I don't really recommend doing that. I like to kind of keep everything in the factored form and then go ahead and cancel things out. So it is kind of up to you either way how you do it. So I know actually, like in fact, I know this one nothing will cancel right away. So we could actually go ahead and do FOIL and clean these up. So um, why don't we actually do that for this one? So let's do FOIL. So we're going to do x times x. So we'll get x squared. Then we're going to have x times 2x. And then we're going to have 5 times x. And then we have 5 times 2, 10. I'm going to draw a big line over this because I'm going to add the numerators together. So I'm now going to do FOIL for this one. X times x is x squared. Also, sometimes when I do this, I do kind of institute a big bracket. Okay, we don't need it in this one because we're adding. But if this was a minus sign, I would definitely need a large bracket here when I do FOIL to put everything in, because I got to subtract every single thing that's in here. So it is kind of important to put those brackets in. So x times negative 3 minus 3x. Negative 7 times x minus 7x. And then we have negative 7 times 3, positive 21. And this is all over x minus 3, x plus 2. So we don't want to do FOIL with our common denominator. We want to leave that. Okay. So let's go ahead. We're going to collect like terms with all of this. So as you might have noticed, I already kind of ran out of space. So we're just going to squeeze this a bit. And I'll zoom in and we can finish. Okay, so x squared plus an x squared. I'm just kind of crossing them out so that I don't miss anything. We'll have a 2x squared for that. And then 2x and 5x, that makes 7x. And negative 3x minus 7x over here, that makes negative 10x. Okay, 7x plus a negative 10x is going to give me minus 3x. Okay, so I now have taken care of those that I did. And we have 10 plus 21. 10 plus 21, that's all that's left. 31. And this is all over x minus 3, x plus 2. So it is important to keep this factor down here because maybe we can do some factoring with this, and then maybe some factors might cancel. Okay, we can only cancel common factors, so it's best for us to kind of take a look at this and see if there are any, if it's possible for us to do any factoring with that. Okay, so this actually is not factorable in this case, this one here. So you could try to do decomposition where you multiply those two and get 62, but you're going to notice there's no product for 62 that adds up to negative 3. Okay, it does not exist, so we kind of just have to stop here with this one. And don't worry that this is factored and this part isn't. That's okay. This is as simplified as much as it can get. We'll just state our restrictions. So starting back with the original question, we have one here for this one. So I'll go back and I'll just kind of write these in different colors. So this one, we have 3. X cannot be 3 for that term, and x cannot be negative 2 for this term. Okay. Both those take care of each line all the way through. So we can just go ahead and state those in ascending order, negative 2 and 3. Okay. So that is the first one for part A. Okay, just going to compress it a little bit more, and that should be good for there. Okay, and the last one. So now we have some trinomials here. Okay, remember we want to subtract these expressions. So there's rational expressions. So in order to do that, we need to get a common denominator. How am I going to get a common denominator for this? Well, let's see if we can factor these. Once we get it factored, we might be able to see some common factors and then also get a lowest common multiple. So first step is to factor. So let's take care of this one. Negative 48. That's simple trinomial factoring. Two numbers that multiply to negative 48 and add to 2. So we could do 8 and negative 6. Okay, that multiplies to negative 48 and adds to 2. So that will be the first one. So let's go ahead. We can write this out. X plus 9 over x plus 8, x minus 6. Okay, and that's going to be minus the next one, this one here. So multiplies to negative 30 and adds to negative 1. You guys probably already guessed it, negative 6 and 5. That's the product of negative 30 and adds to negative 1. X minus 6, x plus 5. Okay, and in the numerator we have x minus 9. Okay, I'm just going to move that over a little bit. Okay, it's a 5 there, x plus 5. Okay, so now we need a lowest common multiple. All right, so can see here, because it's factored, they each have an x minus 6. So my lowest common multiple should have an x minus 6 in it. Okay. And now, what else will I need so that everything's going to look the same? Well, I can see one of them as an x minus 6, the other one as an x plus 5. So if I include those in here, both of them, then that will become my lowest common multiple. Okay, so over just a bit. So we will have to use an x plus 8 and then an x plus 5. So all three of these terms are needed for my lowest common multiple. So just to go ahead and check, this term here, if I multiply this by an x plus 5, I get this here. Okay, this one, if I multiply this by an x plus 8, then I get this here because I'll have that x plus 8 added in. So that's the lowest common multiple. So to do these, I really just look for what's common. Anything that's common, I write that down first. And then I just grab all the extra factors and I make sure I include them in. All right, now we can go ahead and multiply these by whatever is needed to get the common denominator. So let's write this right here. So we have x plus 9. That's going to be over x plus 8 times x minus 6. Okay, I'm just going to shorten that a little bit there. And we're going to multiply this by an x plus 5. Okay, and I just kind of put some brackets around it. So, okay, we do it for both the denominator and numerator. The other term, we have x minus 6, x plus 5. Okay, we need to multiply this by an x plus 8. Both numerator and denominator. So now you can see we got the nice common denominator. So I'm going to use that in my next line. So if you want, you could even do this at this point. You can write those down. X plus 8, x minus 6, x plus 5. And then up here, I'm going to start to write this out, the subtraction of the two numerators. So the first term, we had x plus 9 times x plus 5, and that's going to be minus the second set, x minus 9 times x plus 8. Okay, so you can see we have this here, and then it's minus the product of those two, which I have there. Okay, leave this denominator factored, but go ahead and do FOIL for these up here. Okay, I'm going to do this quickly because I know you guys have had a lot of practice with FOIL now. When I do this, I add the middle terms together. So x times x is x squared. And then I know I'm going to have a 9x and a 5x. That's going to give me 14x. And then 9 times 5 is 45. Okay, minus the next one I got to keep in a bracket. So I'm going to do FOIL for this. My middle terms are going to be negative 9x plus 8x. Okay, so that is a negative 9. Let me clean that up a bit. So we have negative 9x plus 8x. It's going to give me just negative x for the middle term. So I'll have x squared minus x, and then negative 9 and 8 is 72, negative 72. Okay, this is all over those three binomials. Okay, I can almost fit this in. So be careful with this bracket and the minus sign. Remember, we're going to have to distribute the negative in to each term. So if you want, we could try to squeeze this all in up here. Sometimes I just simplify in that line right above instead of writing everything out again, but it's going to make sure we kind of have everything done properly. Okay, so to drop the brackets, I had to change the sign of every term. Then we have x plus 8, x minus 6, x plus 5. Okay. And I can easily see what cancels out, like x squared, for instance, with this x squared. So, oops, we're going to go ahead, we're going to continue this right here. So 14x and x, that gives me 15x. And then 45 plus 72, that's going to be it's going to be 117. Yeah, 117. So we'll write that right here, plus 117. Okay, and all that is over those factors still. X plus 8, x minus 6, x plus 5. So you can kind of see here, yeah, I don't think we're going to be able to do any factoring with this. Try to look for a greatest common factor, and obviously it doesn't exist for this one. So if there was, I would maybe try to cancel something out, but there are no factors up here, so we got to leave it the way it is. We're just going to state our restriction. So the nice thing about these questions when you're adding and subtracting is that our zeros kind of stay the same all the way through in the denominator. So you can almost just kind of look at the last line here. So I know x can't be negative 8, 6, and negative 5. So the reason why I'm looking at just the last line is because I know nothing was canceled out. So that's kind of what you need to really be careful for. So write them in nice ascending order. Negative 8, negative 5, 6. So that's adding and subtracting rational expressions. We're now going to look at an application. So Raj and Mac are competing as a relay team in a 50-kilometer cycling race. There are two legs in the race. Leg A is 30 kilometers and leg B is 20 kilometers. Assuming that each cyclist travels at a different average speed, determine a simplified expression to represent the total time of the race. If Raj can maintain an average speed of 35 kilometers an hour and Mac an average speed of 25 kilometers an hour, determine the minimum time it will take to complete the race. So you probably want the cyclists who can travel faster to do the longer distance one. That way they can win the race. Okay, so let's go ahead. Let's start our solution. So whenever you're doing any kind of distance speed, like distance speed time calculation, you can always use, you can kind of use this expression here, like time equals distance over speed. Okay, you've probably seen this look something like this maybe in previous classes. Speed equals distance over time. So, but we actually we don't really want to use S for speed. It is better to use V for speed. So um, this here just says the total time for the race is going to be the distance divided by the speed. So we're going to follow something like this um, to get our kind of a nice solution. So D is just the distance, and V is for speed. So the reason why you see it as V is because uh, it kind of has to do with physics. So in physics, speed is kind of related with velocity, and they use V for it. So I know probably in other years you've seen speed as the symbol S, right? S for speed, but V is actually a little bit more appropriate. Okay, so we're asked to write a simplified expression and represent the total time of the race. So we're going to have total time. So we'll say time total. It's going to equal time for leg A plus time for leg B. Okay. Leg A is 30, leg B is 20. So they're each going to have their own times. And we just add them up to get the total. No big deal. Okay, the time that it's going to take for leg A, well, that it's going to be the distance of A divided by the speed that we travel at for leg A. And the total time for B is going to be the distance for leg B divided by the speed of leg B. So all I did was I just applied this distance over speed, which is equivalent to time. I applied it to each one. So I kind of kept the same subscript. So time for B is just distance of B over the speed of B. All right, and we'll just kind of finish this up here. So the distance for leg A, well, we're told that it's 30. So we can actually write this as 30 over the speed of leg A plus distance of B is 20 over the speed for that leg. So you can see this kind of looks like a rational expression now. That's what they want, a simplified expression. So here we have two terms, two rational expressions. Well, let's add them and get one simplified one. So my lowest common multiple is going to be VA times VB. The LCM is going to be VA times VB. So we can actually see what we need to multiply here. I gotta multiply this one by VB, denominator and numerator, and this one by VA. Okay. So we would have 30 VB over VA VB plus 20 VA over, I'm going to write it VA VB. I know it's VB times VA, but that means the same thing, right? If we write it that way instead. We got a nice common denominator, so we can just add the numerators, right? So my simplified expression is going to be 30 times the speed for B plus 20 times the speed for A. That's all over VA VB. All right, so yeah, that's our simplified expression. Part B, determine the minimum time it'll take if Raj can go 35 and Matt can go 25 kilometers an hour. So we do want to put the we do want to make sure you put the right speed in the right leg. So leg B is shorter, right? So leg B is shorter, so we'll put 25 kilometer an hour Mac in leg B, and we'll put Raj in leg A. So by that I mean VA, because it's a greater distance, we'll have the faster one going 35 kilometers an hour. And for B, we'll put the 25 kilometer an hour. So our total time is going to equal 30 times VB, which is 25, plus 20 times VA, 35, all over 35 times 25. And crunching all those numbers, you get something approximately equal to 1.66, and that's going to be in hours because it's kilometers per hour. We can just say, therefore, it will take 1.66 hours to complete the race. Okay, this is actually the fastest time, right? You'd probably add that in there. Okay, that is it for 2.2. I will see you in the next lesson.